Hey everybody, Wire here, we're back. This is going to be part 2 of this Transoceanic radio restore. What we're going to do is we're going to work on the chassis in this part and clean it up and try to get it running, change some of the capacitors and resistors in it. And actually, we're going to try to fire it up before we do any of that. See if we can get it working and see what we got to do to it to get it to 100%. Anyway, let's start. What we're going to do is take his dial face off and put it on the side and get this down to just a bare chassis. So this is pretty easy to do. And I believe this front dial is plastic. There's 4 screws, a 1/4 inch. I'm really hoping this works because I think it's a pretty cool radio. Somebody worked on this before because this is cracked in the corner and there's supposed to be a washer behind here and the washer is missing, so we will put a washer behind it. Everything came off. And yeah, this is plastic and this is metal, so let's put this off to the side. As you can see, the dial strings are broke. This is bent. Take these off. Let's stash these somewhere so we don't lose them. That was left over from the mouse that used to live here. Like I said, this is bent. Let's try to bend that a little bit straighter. This has got to line up with this one here, I believe. It's one. This goes around here. I don't know. I got to look at the schematics on how this gets 3 strung. I believe it's 3 strings, but we'll see. Anyway, let me get this set up so we can look up underneath of it again and see what we got to do to it. We'll be right back. Okay, first thing we're going to do is see if this right here, this selenium rectifier, works. If not, we're going to change it. I'll show you to you in the schematics. It's got to be 105 volts on the output from this this resistor here. So what we're going to do is we're going to take a reading on this and see what the voltage is right here. Right now I got 119 volts coming out of my light socket. Let me get this hooked up and we'll take a reading. We'll see what it is on here. We'll be right back. Okay, like I showed you in the on the radio, the selenium rectifier. This is the selenium rectifier right here, and as you can see, it's a half wave. It changes alternating current into DC current, and what we're going to do is we're going to test this. This is the 130 ohm resistor. And on the other end, this has got to be 105 volts. Okay, we're going to test it right here and see actually we're going to see how much voltage we got coming out of the socket, the light socket first is. And if it's 115, so it's got to measure 115 here, and this dropping resistor should be 105. If this is anything lower than or higher than 115, and it doesn't match what's coming out of the light socket, we're going to change this, put in a 1N4007 diode, and we'll probably have to change the dropping resistor so this matches 105 volts. Diodes are a little bit more efficient, and it might be a little bit higher up here, and we can't have it any higher than 105 and no lower than 100. So let's get the radio set up. I'm going to do that test and see what this value is on this. Okay, we are getting 117 volts to the chassis, but we're not getting anything off of this rectifier. So let me hook that back up and see what we have here, because it is working. So this rectifier isn't working at all. So we're going to have to change that. We will try to fire it up there with the tubes in it and see if anything happens. But as you can see, we're only getting like a half a volt VAC, so this rectifier might be burned out. I don't know. Let's put the tubes on and see if we can get a station in it or whatever. We'll be right back. Okay, we got this plugged into my dim bulb tester. Put the tubes back in and let's fire it up and see if we get anything. The bulb tester didn't turn on, so we might not be getting anything. Something might be burnt out. We'll let this heat up a little bit, and we'll see what's going on. Now, none of the tubes are lighting up. Let me turn this light off for a minute. No, none of the tubes are lighting up. I'm going to have to track this down and see what's going on, and see if we can get this working, because it is not working. And it's completely dead. So let me turn this upside down and see what's going on. Okay, we tried to power this up with all the tubes in it, and I thought maybe we had a problem with this wafer switch down here. What that wafer switch is when you're on battery power, you plug the plug in that and you can run battery power. We're not going to be doing that. So I cleaned that up, and it wasn't that. I did hook this back up to the positive side of the rectifier. Let me turn it on. Let me show you what's going on here. We're only getting 100 volts out of this rectifier. These selenium rectifiers aren't efficient. So what we're going to do is we are getting power to it. I suspect something in here is blown out. We're going to change these capacitors and see if we can get this going. I didn't get anything on this side of the resistor. I'm thinking this resistor is open. We can test it and see what's going on. We'll do that. But like I said, this should be at least 115 volts coming AC, well DC coming out of this, and we're only at 100 volts. So with that being 100 volts and this dropping resistor being 130 ohms, well, we're only probably getting maybe 90 or 90. Well, actually, we're not getting anything over here, but it should be like around 95 ohms coming out of here. But this may be open. So let's check that, and we'll go from there. Let me unplug this. Okay, before I unplug it and we test this, This dropping resistor is working, so that's okay. And as you can see, we're only getting 91 volts out of this thing. So we're at least 15 volts less than what we should be. So that's going to be taken out. We'll do that last. I always like doing that last. That way I'd like to have all new circuitry in here before we change the diode in this. Anyway, I think what we're going to do is start replacing all these capacitors here. Let me turn this off. I don't want to get shocked. We replace all these capacitors. Here's a capacitor right here. There's caps here. This is an aftermarket. This was put in a little later. This was put in a little later. We're going to change all these. And there's a filter capacitor in here. We'll do that last. I just want to see if we can reform that and just use what's in there. If not, I'll completely change that too. Anyway, let me replace a couple of these things, and we'll be right back. Okay, I recapped everything in this radio. Here's all the capacitors I took out of it. I didn't take the filter capacitor out of it because I really don't think there's anything wrong with it. That has nothing to do with it operating. It just filters out the hum. So I did put a diode in here, and I'm going to measure the voltage and see how much voltage we have at the B plus on this thing. So watch that. We have 155 volts, which is way too much. So what I'm going to have to do is, I don't have any 10 watt resistors. I got to get a 10 watt resistor and figure out how much I need to put on there to get that down to 105. Anyway, fellas, we'll have to pick this up the next time. Next thing we're going to have to do is go through all these resistors and see if any are out of tolerance. But I'll catch you guys next time. This is Wire. See ya.